You hit enter. Nothing happens for a moment, then text starts streaming in, word by word. But what actually happened in that gap? Here's the thing, your prompt didn't get read the way you'd read it, top to bottom. It got read all at once, like a factory processing an entire order in one shot. Then something completely different kicks in. The reply gets written one piece at a time, like a chef cooking a single dish, step by step, never skipping ahead. Same request, two totally different machines underneath. We're going to follow one prompt through both of them, start to finish. So, what is the factory actually doing? It's building something called a KV cache, basically a running memory of every token it's already read. And that whole pass is compute bound, meaning it's limited by raw GPU math, not memory. Then decode starts. The chef only needs the ingredients for the very next bite. Every prior token gets pulled straight from that cache instead of recomputed. That's the twist. Decode isn't compute bound at all. It's bottlenecked by how fast the GPU can move that cached data. Two phases, two completely different constraints, back to back, on every single request you send. Why split the job like that at all? Because the two phases physically can't be optimized the same way. Prefill wants raw math throughput. Throw more compute at it, it goes faster. Decode doesn't care about compute. It's waiting on memory bandwidth, on how fast the GPU can drag cache data back and forth, one token at a time. You can't fix one bottleneck by throwing the other phase's solution at it. That's the constraint. And it's exactly why time to first token and steady streaming speed behave like two different problems. Because under the hood, they are two different problems, running on two different limits. Let's put real numbers on this. A long rack prompt, thousands of tokens stuffed in as context. That's why your time to first token creeps up. You're waiting on the factory, not the chef. And once words start appearing, there's a real speed target. About 100 milliseconds per token, roughly 10 a second, is where streaming feels smooth. Drop to 3 or 4 tokens a second, and readers feel the lag, even with a great answer. Here's the trade-off nobody tells you. Batch more requests together and you boost throughput, sure, but every individual user waits longer. Optimize for one person's speed and you serve fewer people at once. That's not a bug, that's a business decision. So, what do you actually do with that trade-off? Think of it as picking your restaurant. Run a dedicated kitchen for one table, small batches, maybe one request at a time, and that chef gets your dish out fast, low latency, perfect for a chatbot where someone's staring at the screen waiting for the first word. Or run the kitchen at full capacity, dozens of orders going at once, and you serve way more people per hour, but any one table waits longer between bites. Neither option is wrong. A live support agent needs the first kitchen. A batch job summarizing 10,000 documents overnight wants the second. The mistake is not choosing on purpose. Okay, so what do you do with all this? Next time your app feels slow, don't just shrug and blame the model. Go check which phase is hurting you. Is it a sluggish first token because your prompt's bloated with context? Or is it choppy streaming once the words start? Those are different bugs with different fixes. Trim your prompt for one, rethink your batching for the other. That's the actual skill here, reading the symptom back to the phase that caused it. Now, I want to hear from you. What part of the stack should we tear open next? Drop it in the comments.